Adam Bress, faculty in Department of Population Health Sciences, and it is my honor to introduce our closing keynote speaker for the day, Erica Check-Hayden. Erica is the director of the Science Communication Program at the UC Santa Cruz. She holds a degree in biology from Stanford and is an award-winning science journalist and a Pulitzer Center grantee. She was a reporter for Nature for 15 years, where she has written several influential stories on topics such as genetics, personalized medicine, and infectious diseases. For example, her story on the first $1,000 genome and her story on the 10-year anniversary of the Human Genome Project have each been cited over 100 times according to Google Scholar. In December 2014, Erica traveled to Sierra Leone to report on the Ebola epidemic and the response, and her reporting there received second place in the Association of Healthcare Journalists Award for Excellence in Healthcare Journalism. So with that, please join me in welcoming Erica Check-Hayden.
Thank you so much. And just to clear up any confusion, can I talk here? Is this okay? I'm big. Sorry. The Pulitzer Center grant is not the same thing as a Pulitzer Prize, okay? I did not win the Pulitzer Prize. The Pulitzer Center is a wonderful organization that supports journalists to travel and cover stories. So I received that grant to cover the Ebola epidemic in Sierra Leone in 2014. It's an excellent organization. So thanks for having me here today. It's been so fun to listen to all of these talks. As Adam mentioned, I've been covering genetics and genomics for a really long time, and so it's really exciting for me to see how far this technology has come and the breakthroughs that you are on the cusp of rolling out to make a broader health impact. I titled this talk Telling Your Story, and the whys in parentheses, because I think increasingly we're not talking about doing research that's having impact on patients, and the patients are like some people other than us, right? Increasingly this is about public health impacts, and that's about all of us. This is my Twitter account, so if you want to see links to the stories that I'm going to talk about today, I tweeted out a link to those there, so you can find that. So it's obviously an incredible time to just be a human being and to be on the cusp of all these incredible breakthroughs. But I think what's important to realize is that the general public isn't really aware of most of the things that we're talking about today. And I think that's very important because increasingly, as we've heard today, the public is more and more involved in this research, not just as participants, but also as driving the research and setting priorities. And that's really important because public understanding of science matters now more than ever. And it's the kinds of breakthroughs that you're talking about that illustrate this. So, my first slide. So these are some of the things that we've already been discussing a little bit today, and they're emblematic of the way that the public is participating in research in new ways. So these are some of the consumer genetic tests that we've already talked about a bit. This is just a screenshot from the Apple Research Kit webpage. So the Research Kit is an iPhone app that you can download and participate in all kinds of these health studies, and there's more of them being added all the time. And then this graph is a family tree that includes 13 million people. And I don't know if you saw this study that it came from, but this was a study published in Science earlier this month, led by researchers at the New York Genome Center. And what they did is they took public data that users uploaded to a genealogy website, and they looked through these records that are just genealogical records, and they assembled them into this very large family tree. And they were able to do some science with this tree. So this particular one spanned back, I think, an average of 11 generations. And they did a little bit of science. So they used this tree to calculate an estimate for the heritability of longevity. And the heritability they got with their data was about 16%, which is actually at the lower end of some of the estimates for heritability of longevity that have been estimated by, for instance, twin studies. So I think it's a pretty cool example of some of the ways that the public can be involved in research these days. But that opens up some tensions, because now we're talking about some new types of relationships that we're forming. And as this research comes to have a much broader health impact, it's important to realize that the assumptions that we might make about what the public wants from this research might not fit with what the public actually does want and expect from this research. And so that's what I'm going to talk about today. I'm going to talk about 2 case studies that exemplify how much we should not assume what the public wants from this research, and how there may be ways that we think that we are helping, we mean the scientific community, that are actually not and might actually hurt. So the first case study that I want to talk about has to do with the CRISPR genetic technology. And I wanted to start off by talking about our opinions in the room about CRISPR genetic technology and how it should be used. So as you all, I am sure know, CRISPR is a gene editing technology that you can use as scientists to edit specific genes in all kinds of genomes, and it's taking biology research by storm. It's being used in labs all over the place, and I'm sure here. And it's being investigated as a potential way to treat diseases in many different scenarios. And it's these scenarios that are sort of coming into question as scientists are trying to decide, how should we use CRISPR? And so this is what I want to talk about right now. So the first set of questions is going to concern your thoughts and opinions about how you would want to use CRISPR in yourself as an individual. And the first question is, if you were living with a fatal genetic disease, and the example I'm giving is, for instance, Huntington's disease, and you could use CRISPR to edit out the genetic mutation that causes this disease, how many of you would do it, just by a show of hands? Okay, and how many would not? Okay, so this one person. So this one is pretty much a very, very strong majority in favor of using CRISPR. So I'm going to mark that. The second question is, again, thinking about yourself as an individual potentially using CRISPR. But instead of using CRISPR to edit a mutation causing a fatal genetic disease, this would be to edit a mutation that causes a significant disability, such as the examples I'm giving are blindness or deafness. So this is not necessarily something that is fatal, but it causes a significant disability. So how many of you would do CRISPR in that instance? And how many would not? Couple more, few more would not. Okay. So the final situation is thinking about CRISPR for yourself, but thinking about a genetic predisposition to disease. So this is that you have a genetic trait that increases the risk for a disease, doesn't necessarily cause the disease. So this is thinking about, say, a genetic trait that increases the risk of cancer or the risk of obesity. How many of you would edit that out? Okay, and how many would not? I'd say it's probably about 50-50 on that one. Okay. So the next set of questions is going to look similar, but instead we're thinking not about making a decision about you, yourself, but your child, either your real child or your hypothetical child. It's the hypothetical part, or just that it's a child?
How do you tell whether your child is real or hypothetical?
I'm going to leave that up to you. I'm not here to get metaphysical. So thinking about a child for which you have, healthcare proxy. If your child was living with a genetic mutation causing a fatal genetic disease, such as Huntington's, would you use CRISPR to edit that out of your child's genome? Yes or no? Okay, so a bunch of yeses, a bunch of no's, fewer no's. And you can probably guess what the next question is. Would you use CRISPR to edit a gene out of your child's genome if that gene causes significant disability but not necessarily is fatal? Yes? And no? Okay. Maybe like 10 no's there. And then the final one is the risk predisposition question, thinking about your child. If your child had a risk of developing cancer or obesity that was related to a genetic trait, would you want that trait edited out if you could? Yes? And no? Okay, I think more no's on that one than yeses. So finally, we're going to come to the really controversial stuff, which is using CRISPR in embryos. And as you know, this is a very hot topic about whether CRISPR should be used to edit human embryos. It's in fact already been used in embryos to correct genetic mutations. No children have been born as a result of that, but I think it's probably safe to assume that that's a matter of time. It's more of not an if, but a when. So thinking about an embryo, a hypothetical embryo that you would somehow come to have healthcare custodianship of, probably yours. If your embryo was diagnosed with a gene underlying a fatal disease, would you want that corrected? Yes?
Could you just have another embryo?
Yeah. So this is like one where it gets a little tricky. I mean, yes, and there's already pre-implantation genetic screening, and yes, that these are all true.
Is it our last one?
This is your last set of three. Yeah.
It's your last embryo.
No
but
other.
Right.
I don't have any embryos.
That if you come into possession of one embryo, it's really precious.
And we can't wait. Everything's good.
What?
Like, are there complications?
And we can't wait till the child is born, we have to do it while it's an embryo.
We have to suspend that thought, right?
Yeah, I mean, look, you can see that this is all stuff that comes into play. There are a lot of what ifs and gray areas here, and it's a really hard question to think through. And I'm not going to like write down your answer and call you in 5 years and be like, hey, this is what you said. I'm just trying to get sort of a sense of where you are with this.
You
So
have to pay for it.
I'm sorry. Don't you guys like work in a hospital? I mean, yeah.
Well, President, is this an in vitro embryo or is this a fun-to-make embryo?
I mean, like, I'm going to try to regain control here. Yes, raise your hand for yes or no. It's kind of, I'd say like maybe 60-40 in favor of yes. Does it change if you're thinking about a significant disability? Yes or no? I think it's about kind of the same. And then for a risk predisposition. Yes? A few people would, and no. Okay, well that's really interesting. So the reason I asked that is because a lot of the discussions about how CRISPR technology should be used are going on among scientists and doctors, and you know, it's clear to see that we have some thoughts about how these technologies can and should be used, but most people in the general public have never heard of CRISPR. We're only starting to see some public opinion polling. So I saw there was actually a big poll in the UK a couple of weeks ago where they asked this question about should CRISPR be used to correct genetic defects, and that one was, I think, 3/4 of people said that it should. So this is starting to get out there, but really the science is moving so fast. And I think it's really important because, you know, a couple years ago, the National Academies of Science had this international summit on gene editing in Washington, D.C., and that's what the meeting was for, was to decide what should we be doing with CRISPR. And importantly, there were no patient advocates who were involved in that discussion, and yet the meeting did result in a consensus statement about, what should be done with CRISPR. And so at that time, I was still at Nature, and I was thinking well, the people who are going to be first affected by this are the patients. So I thought I wanted to go out and ask some actual patients, what they thought about how this technology should be used. So that's what I did. So one of the families I talked to is the Weiss family, and this is Ethan Weiss, and he is a cardiologist and a researcher at the University of California, San Francisco. And he and his wife, about, I think 10 years ago, had a daughter, their second daughter. Her name is Ruthie, and this is Ruthie. And when she was born, his wife noticed that she didn't make eye contact with her parents, which is, she instead, her eyes would track back and forth like this. She couldn't focus. So it turned out that she had this symptom, which is called nystagmus, which is, in infants, commonly a symptom of albinism. And albinism is a genetic condition that's caused by insufficient ability to make this pigment melanin. And it did turn out that Ruthie has albinism. Her albinism is related to mutations in her OCA2 genes, and she does have significant vision deficits. So she's legally blind. She needs a lot of assistance to read and to play music. She plays piano. And there's a lot more to her than just her albinism. So she's an avid athlete. She is a skier. She plays basketball. She swims. She's a pretty active young girl. And she has a great quality of life and a really supportive friends and family. And so I asked Ethan, her albinism is related to her genetics, if he had the option to hypothetically go back in time and correct this when Ruthie was a baby, would he have done that? And what do you think he said? How many think he said, yes, I would have corrected it? And how many think he would have said no? Right. And he did say no. But we also knew that Ruthie is the one who is living with albinism, and what her dad thinks might not be the same thing as what she thinks. So Ethan also asked Ruthie, what she would have done, which is a hard thing to think about when you're a kid, but he did ask her, if you somehow had the option to correct this and take this out of your genome so that you would no longer have albinism and you would be able to see, would you do it? And how many think she said yes? And how many think she said no? Okay, so she said no. Okay. And then he asked her this other super hard question for a child to answer, which is, think about yourself as an adult. Say that you want to have kids. Say that you have embryos. If you could use CRISPR to edit these OCA2 mutations out of those embryos so your kids don't have albinism, would you do it? And Ruthie said no, she wouldn't. And it wasn't like she had to think really hard about this. These were her responses without hesitation. And in this case, it's important to say that Ruthie and Ethan are not anti-CRISPR. They're not anti-gene editing on a principle. This is purely a decision that they're thinking about in relation to this individual child who they have and who she is. And importantly, Ethan said it's not just that Ruthie is a great kid and she has a great quality of life and we wouldn't want to change her, and that is all true. But it's also that he feels like some of the things that make her who she is are related to, perhaps, her albinism. So he talked about how determined she is, for instance, as an athlete. So when she first started playing basketball, he says, was the worst player on the team. But she decided that she wanted to get better. And so she took it upon herself to go out and do a ton of extra practice every day. And then the next season, she was the best player on her team, seriously. This is a kid playing on a team who has intense visual acuity with other kids who don't. And she really is the best player on that team. So for him, it's a part of her that he wouldn't want to see erased because he thinks that she has a lot of parts of her personality, and this is one of them. But it's important to say that this is one example, and there are many, many other situations that people are talking about using CRISPR in. So, for instance, there's the situation of Huntington's disease, which is a fatal genetic disease. And there I did talk to patients who had a different opinion about wanting to use CRISPR. So I talked with a man named Charles Sabine, who has an older brother, and they live in the UK. They both have the Huntington mutation. And Charles's older brother, John, is already experiencing the symptoms of Huntington's disease, and they're very severe. So when I asked Charles, would he use CRISPR to edit his genome, his brother's genome, his kid's genomes, any embryo's genome, he was like, yes, I would absolutely do it. He said, if there was a room where I could go in and have my genome edited, I would be knocking down the door. But even in that disease, there are some assumptions that we shouldn't make about what patients would do. So this is an online support community for patients with Huntington's disease in the UK. And you can see that this is a discussion board where patients are talking about the decision to use pre-implantation genetic screening, which is an option if you have Huntington's disease or any disease where the genetic mutation is known. You can make embryos through IVF and screen these embryos for the trait, and then you can pick the embryos that you want implanted. In this case, it would be the embryos that are free of the Huntington mutation. And that way you can guarantee that you won't have a child who has this disease. So you can do this now. This isn't a future technology question. So I talked to a UK physician who treats patients with Huntington's disease, and he actually told me that of his patients who have the mutation and decide to have children, fewer than 5% of them actually choose to use PGS. So when we talked about, somebody mentioned having kids the fun way, this doctor told me that having kids the fun way is still way more popular than having kids the science way, even though that's the way you guarantee that they won't have Huntington's disease. And he said there were a range of reasons why this happens, which I think are important to what we've been talking about today. And part of it is people who have ethical or moral obligations to using it. Part of it is also cost and access. So even though this is probably easier to obtain in the UK because they have nationalized health care, there still is a cost and access issue. And then there's also this calculation that some patients make that the 50-50 odds of passing down the mutation just aren't that bad, and they're willing to take the risk. So I wanted to walk you through these examples because I think they show that decisions that we in this room might think that patients would make about how they want these technologies used are not necessarily the way that patients actually do want these technologies used. And then the flip side of that is that there might be patients who are not being well served by science who really want us to work on their issues. And so that's the second story that I want to talk about. So the second story that I'm going to talk about today is one that I just did earlier this year for Wired, and it concerns NGLY1 disease. So how many of you have heard of NGLY1 disease? So this is one of the diseases that was one of the first that was discovered through next generation sequencing. This is Matt Wilsey. He is a Palo Alto father and technology entrepreneur, and his daughter was one of the very first kids in the world who were discovered to have NGLY1 disease, and that was back in 2013. So that was right after this disease was discovered in another family. And it's Matt's daughter, Grace, who has NGLY1 disease. And she's 8 years old, and at the time that she was diagnosed, really nothing was known about this disease. So it was known that NGLY1 disease is caused by mutations in the NGLY1 gene. It was known that this gene makes a protein that is involved in deglycosylating other proteins, but it was not clear why that would cause, severe mental or physical impairment. These kids have a huge range of physical and mental disabilities, everything from liver problems to inability to make tears to difficulty walking. So Grace didn't walk till she was 3, sleep disturbances, a really huge range of things. And here's Grace, she's sitting in her activity chair in a speech therapy, one-on-one speech therapy session. She doesn't really talk very much, and this is what they call her talker. It's a little device that she uses to communicate with her family and her teachers. So at the time that she was diagnosed about 5 years ago now, nobody could really tell her parents what to expect. They didn't know how long she would live. They didn't know if her disease was going to be progressive. They certainly could not offer her any kind of treatment because this thing hadn't even existed. So the Willses are very resourceful people, and they decided that they would start to fund some science. And so they raised $7 million, and they put together a foundation, and they started going out and convincing scientists to work on NGLY1. And this is their SAB, and you can see some of the people who have agreed to work on NGLY1. They've now funded, they estimate, between 25 to 35 grants, and there's maybe collectively 100 scientists around the world who they think are now studying NGLY1 with their support. So this is what they did. They got a bunch of scientists to work on it, but the scientists told them that it's great that we have this funding, but we really only know about a few patients. If you could find some more, then that would give us some more data to work with and we could make more progress. So Matt and Kristen are very internet savvy, and they started an online support group, and they went out and started finding other families all around the world who also have NGLY1 disease. This is one of the families, so these are the Viga homes, and they live in Denmark. And they, until recently, had 2 kids affected with NGLY1 disease. So this is Victor and this is Bertram. And last year, Bertram became the first child in the world known to have died of complications from NGLY1 disease. So the scientists said, that's great, you now have, at this point, almost 50 families around the world who are known to have this disease, but now we need some materials from them to study. So we need you to get their blood and their spit and microbiome stuff like stool and urine, but they can't just mail it to us, we need to collect it in a certain way. So the Willses fundraised again to bring a lot of families to Palo Alto. And so last summer, they brought 17 families with NGLY1 to Palo Alto and collected a slew of samples from these families, including blood and spit and stool and urine and skin biopsies to make iPS cells. So all of a sudden, NGLY1 disease goes from having very few resources that scientists can use to study it to having a lot. And these resources are all being deposited at Stanford in a new biobank that's devoted to NGLY1. So a lot of science is now being done on NGLY1 with this funding. So this is a paper that Carolyn Fortier published late last year. And it has to do with trying to figure out why this deglycosylation activity of NGLY1 is so important and results in this huge range of symptoms. And she was able to basically figure out that NGLY1 inactivates this transcription factor called NRF1. And NRF1 regulates the proteasome, which is this cellular organelle that's very involved in recycling proteins that the cell wants to get rid of. And this is important because there's a whole class of cancer treatments that are called proteasome inhibitors, and what they do is shut down the proteasome and kill cancer cells. But there's a big problem with these, which is that patients develop resistance to them really fast. Their cells find ways to get around the drugs, they reactivate the proteasomes, and the drugs aren't effective. So the result of Carolyn's, or the implication of Carolyn's research, is that, well, now we have this master regulator of this process. Maybe we could use it to find some way to develop a workaround around these resistance mechanisms to proteasome inhibitors. So tying that all together, where they started out was this extremely rare disease, nothing known about it, to a lot more is known about it, and it ties into much more common disease that maybe more people and maybe companies even want to work on. So Matt Willsey went around and he basically asked dozens of pharma and biotech companies to work on this, and they didn't want to. So he said, okay, I'm a businessman, I can do this myself. He raised $7 million, he started a company, and he wants to try to cure NGLY1 within 5 years, which I know is a tall order, but I can tell you from having watched the way that this family operates, I wouldn't necessarily put it totally out of the question. So, the reason why I wanted to talk to you about these case studies is to show you that patients are taking the genetic information that you are giving them, and they're not necessarily doing with it what you think they will. They might not make the decision that you expect they would. They might take that information and say, okay, thanks for the information. Now what we're going to do is challenge you to take this data and drive it further and push the science. Now, all of this can only work if the public has a good understanding of science. And I think there are a lot of us who are wondering these days whether we can really count on that. And I think there's a lot of concern about the accuracy of any news, not just science news. There's a lot of concern in the science journalism community about, support for the journalism business model. And I think a lot of the questionable stuff that you're seeing out there's a lot of reasons why this can exist. One of them is that it is a hard time to be a science journalist, and we're seeing a lot of layoffs at national and local publications. So I think there are a lot of things that we can do about this. I think it's really galling that this is happening right now, right at the time when the science is advancing to the degree that it's affecting more and more people. So there are incredible stories that you can tell and that we can tell about what is going on with your research. It's also kind of galling because we have more ways to tell those stories now than we ever have before. Right? It's not just print media, it's online media and social media, it's podcasting and videos, and the next thing that is going to come along next year that I can't even tell you what it is right now. So I think there are a lot of things that need to be done about this. I think one of them is that scientists and journalists need to keep working together. I think they need to do this more than they ever have before. I also think that scientists, institutions, and foundations need to become more directly involved in supporting science journalism and science communication. And I know that there are some issues in the relationship between scientists and journalists. So this is a figure that Ed Yong drew up a few years ago. I know that sometimes scientists are really reluctant to talk to journalists because of fears of being misquoted or the science not being accurately represented. And I guess what I'm here to say is that people like professionally trained science journalists like me and like the people who graduate from my program and study in my program are among the strongest constituency for science that exists. We are only doing what we're doing because we love science and we like writing about it and we like sharing science with the public. You can always count on science journalists to care about your science and want to communicate it to the world. You guys are doing really great work with that here at the university. So I met over lunch with a lot of your science communication team, and they're amazing and up to incredible things. I have 2 alums who work here at the University of Utah Marketing and Communications Office, and one of them, Paul Gabrielson, worked with a colleague to develop this podcast that's based around what happened when some cadavers were discovered during a major building renovation here on campus. And I think this is such a cool example of a few things. It's using new media, it's storytelling in a way that makes a local story much more broadly relevant to a national population. So I think that, yes, more of this please. You guys are doing great. And I do think there should be, as I said, more direct support of science journalism enterprise by foundations, agencies, and the scientific enterprise. So these are 2 examples of ways that's already happening. So this is Quanta Magazine, which is a magazine that is supported by the Simons Foundation for Autism Research. They also support another science news enterprise called Spectrum. And you can see that they do a lot of stories on areas of science that are hard to cover in the general media, hard science like physics and computer science. Mosaic is an online science magazine that is supported by the Wellcome Trust UK. And these are just 2 examples. There are many others, and I think increasingly this is going to be a trend that's going to continue. So in closing, I want to thank you. This is the current class of science communicators. They'll be graduating in June, and I look forward to a productive discussion about scientists and journalists working together. Thank you.
Thank you, Erica. That was wonderful. I'd like to invite our out-of-town speakers up to the panel we have 30 minutes for discussion and questions about a wide-ranging topics that were discussed today.
It's the correct way. Thank you.
While we're waiting for the first question, I'll start it off. Rick and the rest of the panel, how do you recommend that we handle the diversity in the subjects or participants in our research in terms of self-identified race, genetic ancestry, or detailed measures of social, cultural environment?
You answered it yourself. We should collect all of that information, collect as much as possible, because depending on what the design of the study is, I mean, a lot of that information could be useful. Self-identified race or ethnicity has some meaning to it, and can be utilized in many studies. So I would suggest that you collect as much as possible, not being relegated to just using one of those. You see what I'm saying? And so, but the bottom line is we need to increase diversity. We're talking about diversity of a small number of subjects already. Let's increase the numbers, and then we can discuss how to parse it out. But we have to, we really have a big job ahead.
Thank you all for coming today and for your fantastic talks. I have a question that I'll start with Erica Check-Hayden, but anybody please jump in. So in an era where science journalism funding is decreasing, how can we as a scientific community really help to bridge the gap between the ivory tower and the public on some of these hard questions? And also, I'd like the panel's input on whether you think that the All of Us program is really going to help bridge that gap or not.
So many ways. So the flip side of less professional science journalists being able to do this work is that as scientists you have an opportunity to drive your message, and that's why Utah is investing so much and such strong resources in its own communications efforts. But as individuals, you have more ways to access the public directly than ever before. And contrary to there's a kind of a feeling out there among scientists, I think, that the public doesn't trust scientists. That is not actually true. It's true for certain types of science where there have been prolonged misinformation and advocacy campaigns to undermine science, such as climate change. But if you look at polling data from, the Pew Center does actual polling data on how much the public trusts scientists, and scientists are more trusted than every other sector in American public life, seriously. And if you look at life scientists, it's even higher. So there's people out there who want to hear from scientists, and you can do whatever range of direct communication you're comfortable with. So you can start a Twitter account for your lab. You can write articles on, there's a website called The Conversation that's just publishes articles by scientists about science. You can work with your university communications office. Here they do an incredible job. They have podcasts, they have press releases, they have beautiful web pages that have information that's being made accessible to the public. So there's a lot that you can do, and I would suggest that you start by contacting Julie Kiefer and her team, because they really know what they're doing.
Yeah, I think some of the best journalists are those who operate probably in their bedroom on their laptop, blogging. You know, I mean, you're right. I mean, you could, there really is no boundary around science journalism now. I mean, you could, and some of these folks aren't necessarily trained in journalism. They just like to write, and they like to, they like science, and you get some interesting blogs.
And it's like, I think in some ways it can be a good thing, because when journalism was stronger, it was more of a gatekeeper. And so, there were people who made decisions about what deserved to be covered. And that's not really so true anymore. So if you get some niche publication that's really interested in your work, you can get a lot of coverage that way.
In the back right, or? No? Or while we're passing the mic, Erica Check-Hayden, what advice do you have for us for working with science journalists, as scientists?
As scientists? Well, one is to please answer our emails. And I know that y'all are really busy. Believe me, now that I am in academia, I understand this in a way that I never did before. But even if you can't respond to a journalist's inquiry, even if you don't have time to comment for a story, it's super helpful if you just write back and say that, actually, I don't have time to do this, but if you recommend somebody else who would, that's really helpful for us. I would also say that, again, you can talk with people like Julie about how to talk to journalists. There's a way to have this conversation where you are getting across the points that you're making, but you're also responding to what the journalist needs to get from you. And what they need to get from you is usually a plain language, very distilled explanation of what you did and why it matters in as relatable terms as you can manage. So, all the details about your methods section and, your many, many colleagues that you would also like to be mentioned in the story, that's not going to make it in. So I would say respond to our emails and try to make what you're saying to us as understandable as possible.
I have a question for Erica, and thank you for the shout out. I appreciate that. I was curious with your articles about Grace and Ruthie, what kind of feedback did you get from those articles, and was the feedback you received from, say, the scientific community any different from the feedback you got from the general public, or do you know?
So I got really interesting feedback from the article about Grace, actually really gratifying feedback. So there was a lot of Facebook feedback about how it was helpful for people who either have rare diseases or this particular rare disease to explain it to their families, because I'm sure that some of you who are working with these patients know this, it is so hard to live with one of these rare diseases. Nobody else knows what you're going through, and they will tell you, maybe your kid will grow out of it, or, oh, well, at least they don't have such and such, other worse disease. So it can be really isolating, and I think that for families who are going through it, it is helpful just to see that somebody else cares and is working on these things. From the scientific community, I think that the reaction, there's definitely been some interesting discussions. I don't necessarily want to talk about them in public here, but I've gotten really, really interesting reactions to both of the stories.
Hi, Alan Morris. I have a follow-up question for Ms. Check-Hayden and for Dr. Rickles. It relates to populism, which is a pretty common subject of consideration, and I suspect you've thought about this a lot more than I have, but I recently heard an interesting assessment of communication. It goes as follows, that from the time of the printing press, the Gutenberg Bible, until about the 1990s, we had one system. And since the mid to late 1990s, we've had a very different system. And the difference between the two is that up until the mid to late 1990s, communication was basically a one-to-many. You have already alluded to this. So the editor of the Washington Post, if you haven't seen the movie, it's definitely worth seeing, made a decision. She decided what would be in the Post and what would go out to the many. Currently, we have a many-to-many communication system where anybody with the most cockamamie ideology can produce millions of communications through Twitter in a matter of an hour. And that enables the propagation of such misinformation that I find it rather frightening. Now, you probably are very familiar with this, but I get emails from the Tea Party. The stuff in those emails is not only frightening, virtually unthinkable. I mean, it's basically one theory of conspiracy after another that basically defies imagination for somebody who's, in my view, thoughtful. What are your thoughts about this and the dangers associated with many-to-many as opposed to one-to-many?
Yes, both of us.
I think the cat is out of the box, or the bag, or whatever. Cage?
Container.
Container,
Of some
right. I mean, so there's no going back, number one. And, we're very individualistic, or at least we're socialized to be that way. And so we accept this as a right? But there's responsibility. And I think that it has created a lot of discomfort across many different communities, and I think that there's going to be pushback, and we'll see how it's resolved, if at all. But I don't see anything going back in terms of this process.
So I think that in the beginning of this whole change in the information ecosystem, the idea was, well, these technology tools are going to be out there, and they're just tools, and they're not favoring any one particular group, and they're going to democratize information. And yes and no. I think that what's happening now, and especially in the wake of the presidential election, is that people are sort of realizing that you can't just be agnostic to the platform and assume that the best information is going to rise to the top, for two reasons. I mean, one is that, political scientists and social scientists are now doing these studies where they look at fake news and they see that actually it spreads longer and faster and farther than true news. So it is not necessarily true that the best information rises to the top. And two, there are organizations and groups that are exploiting the nature of these platforms and investing a ton of resources into using them to promote agendas. And so this is why I say that, scientific organizations need to be more involved in communication, is you can't expect that if there is, a country or an organization that is spending billions of dollars to use these platforms to get their message across, that you're going to be able to, somehow counter that just by producing, one really great video. So I think that we sort of need to rethink our expectations for these platforms, and we can't expect that if we just go on doing the same thing that we're doing, that we're somehow going to be able to compete with some organizations that are literally spending billions of dollars to exploit the way that they're formed.
Hi, this is a question for anyone on the panel, but these stories that, for example, Erica Check-Hayden shared about the Willis family and GLI1 deficiency in general are really stories of families with means and time to advocate for their patients. Most families can't raise $7 million to give out to scientists. And so I'm wondering from any of your experiences how these stories impact kind of regular patients or patients with lower SEFs and can't even take off time from their job to take their kids to the doctors. How do they find these types of stories inspirational, or does it just kind of leave them more, I don't know, dejected about their situation?
I think that's a great question, and I really don't know the answer to it. I mean, I think that'd be a great study to actually do, to understand the ways in which different stories presented in the media, how that impacts individuals and families and their thought process about whether or not something is helpful or hurtful, or if they have the wherewithal to do it. I do think, as I'm saying that, one of the things I think we tend to think about from disparities is that people don't have resources and they can't navigate and make the most of the resources that they have. And that certainly is true to some extent, but what I have found is, people have a lot of resilience, and some are very effective at maximizing the resources that they do have. And I think we have to balance, the messages that we put out about disparities with the messages about how people have been able to overcome them. So I think it'd be great to find examples of stories where people who have limited financial means or limited socioeconomic means have been able to do, maybe not raise $7 million, but have been able to do things that have propelled them and have helped and advocated for themselves and have been able to be effective to get what they need to happen.
I just want to throw in one comment that just doesn't come from my expertise, just an observation that social media is itself a resource for people, especially if they have limited financial means, that there's a resource just inherent in the social media that can be sometimes mobilized well.
And I'll comment as a pediatrician who takes care of kids often from families with limited resources, and just a couple of things. One is that if a family has a child with a significant healthcare need, a chronic healthcare need, unless that family has enormous means, they will quickly become a family of limited needs very quickly. These are not situations that middle income or even upper middle class families can absorb the financial impact of. So I think as scientists and as healthcare providers and as good people in the community who want to see these young people taken care of, we need to advocate for our safety nets, things like Medicare, Medicaid, and those kinds of things. And in terms of finding examples of these families that maybe don't have the enormous resources, but that have been able to come to excellent and sometimes treatable diagnoses for their children, those can be found in the Undiagnosed Diseases Network and the Undiagnosed Diseases Program at the NIH, where it really focuses on people who have been through diagnostic odysseys, have been unable to find the diagnosis, and there are teams and teams of physicians, scientists, genetic counselors, and the like who work together to try to come to the end of the diagnostic odyssey for those kids. And usually it does not come up with a treatable diagnosis, but sometimes it does. And I think highlighting those kinds of networks so that more and more families are aware that they exist, and more clinicians are aware that they exist, so that we can get the right people plugged in, is a way to help advocate for those families.
This is actually for the panel. Can you guys comment about trust and engagement in communities around not only testing but implementation of some of the personalized medicine? What are the lessons learned? How can we avoid mistakes that I'm sure we're about to make as we embark in the thinking about this?
Yeah, so, well, first I'll say is that, there's a robust literature on trust and distrust and how that is associated with following through with recommendations or not following through with recommendations. And I think, one of the things in the context of precision medicine, my sense of the data and what we know now is that people have fairly optimistic views about the positive outcomes that will occur as a result of initiatives and strategies and interventions that come forth. So I guess in my mind, the question is, well, how do we make sure we don't screw that up? because people are sort of hopeful and optimistic. I think one of the quickest way to diminish trust is for it to not yield, sort of not be able to, and this is, I think, something that someone has said repeatedly today, is that is not to be able to deliver and meet the expectations that we have as a scientific community, I think, set for ourselves. And so I think we are setting a very high bar that we may or may not be able to meet. And I think that if we're not able to meet it, I think that will be one of the quickest ways to diminish trust. And I think the other ways that the trust will be diminished is if at the end of the day, or close to the end of the day, we have strategies that don't work for people who are at the greatest risk. And that's because, of the way the science is conducted, and it doesn't yield a robust understanding of the nature and distribution of risk and outcomes. I think that will perpetuate distrust, that, this is something that, again, is where things don't work for someone like me.
Mark, did you have a question? Okay. For Angie, and then in the back.
So can I just say, this goes back to like 2 sessions ago, and I was a bit, I'm not sure if the speaker is here. Oh, there he is. You presented some data on genetic counselors and their dislike or distrust or disrespect, I guess, of the DTC community, and I just found that shocking in a sense, the numbers that you presented, and because when you look across many different communities, there is a high level of trust. Genetic counselors are to me, I mean, and I could be wrong, maybe you could help me out here, but they get excited when the community has a higher level of genetic literacy. I mean, they can engage better, they can have more robust discussions with their clients, and so I'm just kind of wondering why there's this level of distrust or dislike for the DTC community.
Great question, and we have some genetic counselors in the audience who could probably weigh in, so I think that'd be good to hear from them. Because I don't know exactly, and I don't think it's fair to pick on genetic counselors, because I think that was just representative of the genetics community at large. I think geneticists themselves, genetic counselors as well, just have a underlying distrust of how DTC has been rolled out, and there's been resistance to the idea that patients could receive rather confusing, sometimes upsetting, and perhaps even erroneous data directly without support. And so, and I don't know that there's the best communication between the two communities, and so some understanding of the things that 23andMe has actually done quite well on their website. But I think even with that, and with this latest reveal that, the breast cancer mutations will be released, and I think people, the concern that people would think they've been tested for BRCA1 and 2, even when they've been tested for basically a snowball on top of the iceberg, I mean, it's still concerning. So, but that's a pretty high number, and it has come down over time, though. So I don't know, anyone want to?
So is it reflective of counselors feeling like they have to clean up the mess that was left by the...
They're very, I wouldn't say that at all. They want to jump in and help patients for sure, but they are overworked in clinic backlog, and to have someone come in over their, erroneous report or a confusing report or not have the report at all is hard and takes the place of other patients. So.
Okay.
And it can be a mess. So the ones that come in with Promethease data where they've looked at genes that aren't even the right gene and not the right condition. So, it's not something that they've done a lot of either. So.
If I might make an observation on this that will not be a popular one, but somebody has to point it out. I'll start by pointing out that historically at FDA, when drugs are proposed to be over-the-counter, the primary constituencies that object are the physicians and the pharmacists. Anytime you cut an intermediary out of the process, you are interfering with their livelihood.
That's a good point.
I was wondering, kind of for the whole panel, if there's a conversation going on with the kind of high school educators and people in the education system to prepare the next generation for this set of data. I mean, I think I didn't learn about false negatives and false positives until halfway through an undergraduate analytical chemistry degree. So I think, is there a role of kind of that conversation, and is that happening?
Yeah, it is very important. That's a great comment. And it is happening. I'm not sure if it's happening at the level that it should be, but, NSF and NIH are very, they're putting a lot of money behind that, and, the training of these, of our young people to prepare for what lies ahead, which is going to be more genetics and genomics. And so I think that's the challenge that we all have to sort of accept, is that we should do better in terms of training and educating the youth, because they're the ones actually that are going to make a lot of these decisions that we're talking about now, or at least carry the flag if they are excited like we are about this.
I'll comment as well that the young people are, so I have 2 teenagers at home, and in terms of being able to filter social media, to be able to entertain the thought that what they're reading is purely for entertainment and has no factual value whatsoever, to be okay with that and to just move on with the day, and sort of separate that just because something has pixels or print doesn't make it true, is something that they're very good at. And I think there's a piece of that can evolve into cynicism, right? That they could be pushed to the point where they just don't trust anybody, and make up their own truths all the time. But I think a lot of the young people right now instead are at a point where they realize, like, oh, this is just information, and I get to explore and figure out what is real. You adults are doing a crappy job, and we're going to come up with a new way. And I think they might just do it. They come up with a new way of presenting the real information apart from the fake information in a way that we can't predict today. So in addition to understanding genomics, I think they're going to be able to understand how to understand the next new thing a lot better than we can.
So related to a lot of these different conversations and a lot of these different talks today is, what are we thinking about in terms of communication, right? So you're talking about scientific communication, and you're talking about people maybe not being able to understand this information. I mean, I think it's, that they're getting, and even if somebody else talked about providers not being able to understand the information that they're getting. Perfect example that I gave last year at this conference is my son got genetic testing done. The pediatrician from University of Michigan said, it's something. You can talk to a genetic counselor, and then luckily, my postdoc was a geneticist, and so I called her up, but most people don't have postdocs that they can call up real quick. So what are we doing, and it'd be great to hear from multiple perspectives of trying to communicate this information to patients, whether it's through these direct-to-consumer advertising or just in your clinicians' offices, because we can't, as wonderful as genetic counselors are, there aren't enough of them to do this job. So how are we going to help facilitate this on multiple ends? It's just a quick, easy question to end the day with.
We need to improve science education in the schools to begin with.
Yeah. I think there's something, I think we're getting better. There's some newspapers now that when they report the weather, they'll report a confidence interval around their prediction of the rain. And no joke, I think this is wonderful. And it shows people that, yes, there's an 80% chance of rain tomorrow, and I'm super confident that that's true. There's a 40% rain on Wednesday, and the confidence intervals are very wide. And I think including things in those lower risk scenarios across the board can be really helpful in helping us develop a language, a layperson's language around these technical terms that we have to kick around in science.
I just have 2 observations on that, and one of them is that I think there's even, the technology and the standards are moving so fast that I think scientists talking to each other aren't necessarily in agreement about most of these things. So I'm working on a story right now that I have this, it's like a genome sequencing paper, and I looked at it, and I sent it to, it passed peer review, it is going to be published, and then I send it to, a bunch of people to comment on it, and they're like, this is trash, this is garbage, like they needed to do these sets of controls that they didn't do, I can't believe it's being published. So there's so much going on that I don't think it's surprising that there's all of this like confusion about who we're communicating with and how. And then the other thing I would say is actually that I think one of the other speakers mentioned this today, that some of these companies that are doing the direct-to-consumer testing are actually doing a really good job of trying to come up with models for communicating things like genetic risk. So if you've had your testing done by 23andMe, like the infographics that they're making and the ways that they're thinking about, communicating about these things is something worth looking at. Because it's in their, business model to have these things be understandable for the public.
I was just going to say that part of the FDA process has also been studying consumer understanding of the way the information is being conveyed. So that's one of the ways the FDA is jumping in and helping on that.
So I agree. It's funny because science has always been contentious. That's what science is about. It's about arguing your point back and forth, and whoever's standing up last or told the best story wins, right? Or can convince three of his buddies to say yes to a paper that'll get published. So there's always going to be contention. What I find exciting, and this is why I like DTC, it's not just because I have part ownership in one of the companies, but no, seriously though, if it wasn't for the DTC movement in the early, it started around 2000, it increased the genetic literacy along the landscape enormously. Okay, just that alone, that contribution alone has been phenomenal. Now, and I'm going to put it like this. In the African American community, we didn't know much, I'm not going to say we didn't know much. We didn't discuss or talk a lot about DNA and biomarkers until the O.J. Simpson trial, okay? And then it was mass confusion. It was like, we don't trust this. And then, as some of the testing companies emerged and folks started talking and they started setting up these genealogy groups and all of these study groups, folks started talking, communicating on the internet, and setting up these chat groups and all of that, the discourse became a lot more higher and sophisticated. And you find that across many communities, these old women or these young kids are having discussions about genetics that they never would have had before. And I think a lot of it has to do with DTC.
Well, we should probably end there. First, thank you so much to our amazing speakers and moderators. And thank you all so much for coming today. On behalf of Will and George and the organizing committee, I would just like to take a moment to thank a few people who made this amazing event possible. It was a broad team effort. Thanks to Samantha, who I can see outside through the window, Audrey Mitchell, who's about to come in now as well, Julie Kiefer, Bridget Dunbeck. So thank you so much. And then quickly, thanks to our sponsors, the University of Utah School of Medicine, the S.J. Quinney College of Law and its Center for Law and Biomedical Sciences, and the Huntsman Cancer Institute. So that concludes this, the Frontiers in Precision Medicine 3 for 2018. The conference video will be posted on our website. And thank you so much again for your participation today. Join us outside the auditorium for refreshments.
Can I say something? Adam is not taking any credit for anything here, and he worked a tremendous amount this. We also should thank him because he put a lot of time.
Great.
So which company is it?
African ancestry.
Okay.